Hi, I'm Richard McDougall from the CTO office and R&D of VMware, and I managed to find Amar from Cloudera and get a little bit of time to ask some questions and have a bit of a chat about Hadoop and the Hadoop ecosystem. So
sure.
Maybe you could introduce yourself quickly.
Yeah, so Amar Al-Dalla, I'm one of the founders for Cloudera. I'm also the serve as the Chief Technology Officer for the company.
So we're chatting a little bit about Hadoop and some of it, I guess it's of growing importance we're finding in certainly every VMware customer is asking about Hadoop and big data and what do I need to do and what do I need to be thinking about. So where are you seeing some of the more important use cases coming in for Hadoop?
Yeah, so I mean, first it's useful to describe what Hadoop is at a very high level. So Hadoop essentially is I refer to it as a data operating system. It's a way to collect data and process data with applications across many servers. So it's very similar to Linux and Windows, except it runs on many servers, and then it provides an abstraction of having a single file system across all of these servers, and then a single job application layer running on top of all of these servers. The common use cases we see, the most common one by far is what's called ETL offload. It's about taking away one of the very heaviest tasks that the database has to do, which is transforming unstructured data to structured data, and then run that transformation inside Hadoop instead, because Hadoop is really good, economically really good for that, but also in terms of technology, it's really suitable. It has been built for that, for doing this kind of batch transformations. So that's the number one use case by far. We see that over and over again across all verticals. It's not ETL is something everybody needs. Once you get, in terms of maturity, once you get comfortable with the ETL use case, then the next use case you usually move into is what we call active archive. And active archive is about, now, okay, I have a year of my data sitting in my Teradata or my Oracle or so on, and as the data gets older, I can't economically justify keeping them there, so I move them to tape. But the problem is when you move them to tape, you can't access the data anymore. It's dead. So with active archive, the idea there is, because Hadoop brings down the economics much cheaper than a database, still more expensive than tape, but much cheaper than a database, that now you have a justification to keep your data online in active form.
Okay.
So usually ETL offload comes first, active archive comes next, and then the last use case is what we call advanced analytics. And this is really different by industry and how they look at it. So in financial will be fraud modeling, in web space will be clickstream processing, and in government will be satellite imagery processing, etc., etc.
So we're getting a lot of questions from our customers on just what they should be thinking about when they design a Hadoop cluster. So how big are these clusters that you typically see? What's where you go from dev and test up to production?
Yeah, so usually the clusters, it's funny, I mean, they usually start around 15 nodes. So that's kind of the smallest size. The smallest is 3, but most customers they deploy with 15 at the beginning, and they just keep growing from there, right? So we have customers now all the way in the thousands of nodes, because once they start deploying Hadoop, they start realizing how much economics it brings in terms of storage, and now it hits two birds. It's not just storage, it's also storage coupled with computation. So more and more data starts going to it.
So in the enterprise, what would you say, as I have a guess at the average cluster size?
I would say it's changing every year as the maturity of our customers, as they continue to grow, but also as we absorb customers in new verticals. So in 2009, which was our first year commercializing Hadoop, the average cluster size was around 20 to 30 nodes. In 2010, it was around 70 to 80 nodes. Last year, 2012, actually this year, so last year, 2011, was around 100 to 120 nodes on average. And this year, we're going to see in Hadoop World, that's when we publish that number, I would expect it would be around 200 nodes is the average right now.
So they're really growing.
But that's because we have some older customers who are really pushing the curve, but there's also the newer customers coming in, they're still coming in at the 15, but they grow much quicker.
So from an infrastructure perspective, what do these nodes look like? Are they little tiny nodes with one CPU? Are they big fat nodes?
Yeah, the most common node deployed right now is a node with 2 quad cores or 2 6 cores. I'm not sure how we say 6 as quads. Is there a term for 6?
Hex?
Hex, I guess. Or hex is 8. And then there is about 12 hard disks. Each hard disk is anywhere between 2 terabytes to 4 terabytes. And then about 96 gigabytes of RAM. That's kind of the most commonly deployed footprint for a node.
Is there a rule of thumb there? You said 12 disks, 24?
Yeah, usually the rule of thumb is 1 core per disk. But then it depends. It depends on the workload, right? So if you're doing a workload which is very CPU intensive, then obviously it would push you towards having more cores. If you're now running in the active archive case, where it's really about archiving the older data, then you move to fatter nodes, right? You do a direct attached storage, and you move to 24 disks per node.
And I guess as we're progressing and adding number of cores, it's gone 64.8, now at 12, 24. You would think that's putting a lot more pressure because they're moving more bandwidth over the network. So do you see a movement also to 10 gigabit Ethernet on the infrastructure?
Absolutely. So very excited. It's starting to happen. I mean, we wanted it a long time ago, and the impediment has been the cost of 10G on the server side, right? So 10G has been going down on the switch side, but not on the server side per se. But yeah, I mean, this year we see lots of announcements from Intel and others where they're going to have 10G ports native on the motherboards, right? So we thought like the 10G is happening for sure, and it will help a lot in this case. And we need even more than 10G over the. So we're very excited following up with the InfiniBand movement. With InfiniBand now we can do 56 megabits per second, and very soon within the next couple of years we do 100 megabits per second per server. Sorry, gigabits. Sorry, thank you for correcting me. Yes, gigabits.
Okay, so there's actually a couple of big infrastructure changes here. Like you mentioned local disks and the InfiniBand network.
Yes.
Many people. So what about SAN and NAS? A lot of people have that environment in infrastructure now. We support local disks or NAS or SAN.
Yes.
I'd say a lot of our customers are using SAN and NAS today. Can they just use that for Hadoop? Or
that's a very good question. So they can absolutely use it for the smaller clusters. So when you have a small cluster on the order of 15 nodes to maybe 30 nodes, using shared storage, no problem, and the bandwidth can sustain, and there's no issues there. But the problem once you're going into the hundreds of nodes, the amount of bandwidth you can get from local disk cannot be matched by shared storage infrastructure. One of the key things Hadoop does is what we call data locality optimization, so pushing the compute to be as close as possible to the storage. And hence, if you're leveraging local storage, then you don't hit the network at all, and the bandwidth you can get out of your parallel disks is much higher. So very excited about the work that VMware is doing in terms of bringing that into the virtualization layer. Like usually, when you used to ask us 2 years ago, should I run Hadoop on top of virtual environments? The first thing I would say, virtual machines are great, the overhead is very little, but the problem is most virtual environment deployments today depend very heavily on central storage. And hence, once you start running into larger clusters, you're going to start harming yourself. It's not going to scale with you. So very excited about the work that VMware is doing there in terms of bringing the storage into the virtualization layer itself.
Yeah, the current Serengeti that we've released, we've been working together on this, so Cloudera is supported in the Serengeti release. We can have local disks in the platform as well, so we can provision out. Do you see some typical use cases for virtualization in the with the Cloudera platform?
I mean, the use case is just like any other use case for where virtualization makes sense. Which is if you look at the history of how virtualization in the data center was born, it's about consolidation, right? I'm going to have many workloads, different apps running on the same hardware, and I want to be able to multiplex my hardware across these apps because not all of these apps are going to be on all the time. Some of them will be on, some of them will be off, and hence I get better return on my investment. We see the same thing happening at this layer, at this foundation layer of data operating system with other kind of applications. The key thing that we obviously need to be aware of when we do this is with these systems, data is very important. So data doesn't go away, right? When you're looking at a workload where you're simply virtualizing a web server that is ephemeral in state, you don't care. But with Hadoop, you really care about where the data is. So that's kind of the thing that VMware will need to pay attention to, which I know you guys are definitely looking at.
Yeah, we I think our latest release of the Serengeti, we can actually separate out the compute and the data. So there's a way of actually keeping the data and then growing and shrinking the Hadoop as well. But there's a bunch of joint work going on there.
Yeah, but that's the main benefit. I mean, the main benefit is about multiplexing my hardware infrastructure investment across multiple systems, not just one system. So the same thing that happened at the granularity of one node will be happening now at the granularity of the data center.
Right. Yeah. Oh, good. All right. Well, thanks very much for your time.
Absolutely.
Cheers. Thanks.